So is the audio fine? 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 Do we still have static? Do we still have static here? Do we still have static? Alright, can anyone assertive? Alright, study is gone. So we need to wait 5 more minutes for more people to arrive. I don't know, this seems like an obvious bug. So anyway, we need to wait for 4 minutes before everyone arrives. So at least the voice is clear, right? Yeah, it sounds like a robotic voice right here, but we can't do anything about it. So in 2 more minutes we're starting. Yeah, it sounds like a robotic voice right here, but we can't do anything about it. So 2 more minutes we're starting. Alright, so we have this on our agenda today, Linux and system administration. Now, Linux is basically an operating system which is open source, which means the source code is free to use, and because of that, many people have contributed to it, and it has become better and better, and now it's on almost all the servers and even on some supercomputers. And system administration is basically the art of administering the system, be it a network or be it a server or anything. And the sites you use like Facebook, YouTube, or anything, they have a network behind them. They have many computers and many servers for the same thing, so that if one fails, then the system is fault tolerant, and the other starts. And So in case of an attack, it's the system administrator who you know sees if the attack is not so intense, and stuff like that. And you don't need to smoke for system administration anyway. So for any operating system, there are two moving parts. One is kernel and the other is shell. The kernel is the software that talks to the hardware, and the shell is the software that talks to the kernel. So we give input as our commands to the shell, and then the shell uh, tells that to the kernel, and then the kernel communicates with the hardware and does stuff. So Linux was open source, and actually the founder of C, who was so my voice is not clear at all. भाई अपना वाला ईयरफोन दे दो एक बार. क्लियर आ रहा है. Anyway, just forget the robotic voice. You guys don't need to be doing anything from my voice, right? So, Linux is an open source software, and actually, so where I was, yes, the founder of C was Dennis Ritchie, was also a founder of a very good OS, which was Unix at the time, and Unix didn't run on modern systems like in the 80s and 90s. So there was a guy called Richard Stallman, and he started the GNU project, which would be the open source version of Unix. And he was done writing the GNU tools, which is the shell, the tools that run the shell. For example, LSCD and many more that we're gonna cover today. And there was a guy called Linus Torvalds, and he at that time had opened his kernel to all, which was actually a replacement for Minix, actually Unix. So the operating system that we use, like Mac OS, is also a Unix-like operating system, and it's a fork of Linux. Android is also a fork of Linux, and then the first distribution of Linux came along, which was Debian. So fork is essentially copying the source and then modifying it, and yeah, and then modifying it and distributing it. So you can, for example, take the source code of Debian, copy it, and then call it my Debian or your Debian or whatever. So Linux was forked into Debian, Red Hat, Slackware, and many more. And then Debian is the distribution which is mostly used, which has many forks, and this is the version that beginners should install because it has a lot of documentation. So all the distributions of Linux serve a specific purpose. For example, I'm on Antis Linux, which is about performance. So as you can see, that my desktop environment is as if I'm in the 90s. So that's for performance. Ubuntu is used for software development and coding and all sorts of stuff, because they have really good documentation. And this is the distribution tree of Linux right now. So there are many operating systems, and I'm not going to irritate you by breaking all these pixels. So as Linus Torvalds used to say, talk is cheap. So let's get coding. Alright, so to do anything on Linux, actually anything productive without a graphical user interface, you need something called the terminal. And this is the shell. Alright, so if you look at this prompt, then this is the name of my machine. This is my username, because Linux is a multi-user operating system. And this is the prompt. And this shell prompt tells me that now I can type in commands. So let's type, so let this be displaying hello world. And yeah, it's right here. And there's a command in Linux called date. And what it does is just shows you the time. So let's say we want to print on the screen what the command date says. Now essentially this is not what you should be doing, because date prints it, but just for the sake of demonstration, we need backticks. and then type in the command. Alright, and we can enable escape sequences. If you've programmed before, then you know what escape sequences are. /n is essentially for new line, and then yes, so hi, then a new line, and then hello. And now if you were to use an escape sequence, say backspace, it won't work, because here we need to terminate the new line character by the typing -n. So as you can see, that prompt comes right here, because I've terminated a new line character with -n, which means no more /n is there, and now I can hit backspace, and it essentially does that. Who is for the users who are logged on, and now besides me there is no other user logged on this machine, so it's not going to show anything. W is for logged on users, and statistics of what they are doing. Now this is the uptime, and there is no other user other than me, so it's not going to say. Actually, if I do this, yeah, so it's not going to show anything. Now there's a command called word count, and don't worry about this command, we are going to cover it. If I write, and now I run wc on this file, then it's gonna show me how many lines are there, how many words are there, and how many bytes are there. So this is the number of lines, this is the number of words, and this is the number of bytes. Now we can use pipe, and what pipe there is, it takes the output of the first command and kind of pipes it, throws it to the second command. So let's say we want to see how many files we have. So instead of doing this and then copying and pasting it to that, we can actually use pipe. So what it does is pipe wc. So what this does, it takes the output of the ls command and pipes it to wc. So it's basically like saying wc and then this output. So there are 25 files right here, files and folders to be more specific. Now in Linux everything is a file, and you have just one partition. Like in Windows we have local disk C, local disk D, and all sorts of stuff. In Linux, in one partition there is a root file system, and in that file system you have everything. So /bin is for user binaries, this is for system binaries, and I'm not going to explain it. You can just pause it and see if you want. And for other devices, there is a folder called /mnt where you mount the other devices. So this is for the CD-ROM. So the point is that everything in Linux is a file. And now, speaking of the file system, which starts from /, and then you have the home directories for the users. So if I print out pwd, which essentially just prints the directories, then it shows me /home/ my username. So what this means is, all the users by default, you can actually change it, have their home folders right here. So this is my home folder where all my files are, and if I just start the terminal, then this is where I end. This is the path. Actually, if I change the directory, ls is for listing. If we use ls-l, it basically does long listing, and this is for a directory. D means a directory, and a directory is essentially a folder, and dash means a file. Alright. So, and if we use ls-a, it's going to show us hidden files. Now in Android, what you do for making a file hidden is you add a dot before it. You prepend a dot to it, right? So that's what happens in Linux, because Android is essentially a fork of Linux. So this is showing, and we can actually use these flags in succession. These are called flags for a command. So it's doing long listing, and also showing us the hidden files. A is for all and L is for long. So anyway, and we can change the directory into session. So now it's showing my home directory. This character means home directory, and this is the directory inside the home directory. So we are in. So if we print out pwd, present working directory, home directory, my home directory slash this folder, which means session inside this home directory. All right. So that's it, and so everything in Linux is a file, right? So this ls is also a file. Now, where this file is located, it's actually a program or a command or whatever you want to call it, and where this exists can be found out by using the command which. So this is the file, and now there is a command called file, which tells us what type of file this is. So this is an ELF64-bit file. Now, ELF is for Linux, what exe is for Windows, executable. So the full form is executable linkable format, but we're not going to cover that. So now if we let's say create a file by using touch. So if we use file.txt, it's going to create a file. Now if I perform ls, I can see this file.txt right here. And now to edit this file, there are various command line editors available, but what we are going to do here is nano because it's basic. So let's say I'm writing this. Alright, let's say I'm writing this, and then I want to know what is inside the file. So instead of opening the editor and editing it every time, what I can do is use cat. So cat shows the contents of the file, and this is the contents of this is the test followed by a new line. Alright, so if I actually add a new line here, it's going to show that new line. Yeah. Now there's something called absolute path and there's something called relative path. So if I do this /home/ this is called absolute path, which means I am showing the exact path of the file. But we can also use something called a relative path. So if I do this here, you can see two folders called dot and dot dot, and what this actually means is so if I cd into the dot dot folder, it takes me back into the home directory, and what if I do this again, then it takes me into the home directory /home directory where my home directory resides. And I can use asterisk, which is for wildcard, which means anything that starts with this. So this string followed by anything, a number or special character or whatever. So I'm basically back into my home directory. Now if I cd again, so what this does is this dot dot takes us one level up in the tree. So if we see the file tree, and if we are somewhere here, then what cd dot dot does is it takes us one level up. So it would take us up. Then if you would do it here, then it would take us to the slash directory. So let's keep on doing it. And now we are in the slash directory. Now I can use relative paths. For example, this is for home directory tilde slash, and then I come in right here. And now I can use dot /file dot. Now what dot does is dot is for this directory, which means whatever directory you are in, dot signifies that directory. So if I do this, it's going to take me to the same directory. Now, so we can use dot slash. So this dot essentially means /home/ whatever, and then we can do file.txt. And for example, we have a large file. Let's say I must have a large file here. So don't worry about what these files mean. Just see. Let me see. Yeah. So I can scroll up, but this is not the functionality of a shell. This is the functionality of my graphical window manager. And if I was on a shell, then I wouldn't have this. So what I would do is use more or less as in the command. So if I do more, actually what was the file name? Yeah, more this file, let's say dot slash, then it's then I can use the keyboard for this, or better if I use less. And you know what the wildcard is for anything coming after this string, anything coming after when. So it's gonna take us to this, and then we can hit Q to quit it after we have completed reading it. Alright. And let's say I want to come back into my directory where I'm staying, and I want to create a directory, I want to create a folder. So how can I do that? I can do that with make directory, which is short for this. Let's call it dir. Let's cd into dir. Let's make a file. Actually, let's make another folder called d. Cd into d. Let's make another folder c. Let's come back. Yes, and let's make another folder. So now if you theorize the tree in your mind, then we have a whole lot of files here, and we have some folders. And let's say I want to delete this, so I come here and I use rm. Let's say I want to delete this file, then I'm gonna use remove file.txt, and it's gone. But if I want to delete a directory, this blue color signifies a directory here. Again, this is a function of the window manager. The shell wouldn't allow this, I guess. At least not when I did it. So if I do this, yes. So rm essentially works for files, and since this is a directory, so we have to use a flag called rf. And what that rf means is, so we can essentially say rf, or we can say dash r dash f, like in the ls-la command. So dash r means recursive, which means it's going to recursively go into whatever folders there are, and it's going to delete them. So first of all, it's going into this dir, then it's going to go into this b and delete whatever there is in b. Then it's going to delete, come in d and delete whatever there is in d, and essentially then recursively actually delete this. And dash f means force, which means it's not going to ask me whether I want to delete this or not or whatever. So let's see this, and now it's gone. This is a hidden file, so that's why we have a dot right here. Now next on our agenda is vi. Now we can essentially use many editors, of which this is the most powerful, and once you master this, you don't have to use any IDE, trust me. So let's say, so basically you need to hit I for insert mode, then you need to do this whatever, and then if you hit escape, then it's going to come in the command mode. And now in command mode you can give vim a command, let's say wq, which means write and quit. Now let's say you go here, you come into insert mode, you write something and you don't want this change to appear. So what you do is essentially q this, and what this does is it just quits it without saving the file. Now why is this used for coding? Let's say I'm gonna write a C program here. Actually, C would be, let's say, a Python program, print. And now I'm going to this, and actually, if I want to run the command here, for example, Python, then I'm going to prepare this with an exclamation mark and say, and it's going to run it, and then I press enter and I come back to this, you know, the editor. Now I can quit it. So it can be used as an ID, and now Vim needs a whole class for that matter. So we are not going to do that. And we can actually combine commands. So what are the files we created? We created file.txt and py.py. So what we can do is we can delete these in succession by doing this. Now this will also delete this, but since I want to show you something, actually let me do this. And then as soon as this command is done executing, I want to touch another file called script.py. So what this does is there is a semicolon. This first runs this command, and as soon as this is completed, it runs the second command. So what this command is going to do is it's going to remove these files and then touch another file called script.py. Now if we see, that's actually true. So now you must have seen in memes or whatever that if you do this on a Linux machine, it's going to fuck up the entire system, and it's going to. And now you understand why, because it's going to delete whatever is in the slash directory, which is the main partition, which is the root directory. And this flag means that the root folder and anything pertaining to root will also not be saved. Now I'm not going to do this, of course, but it works, and now you know why. Now since you have Linux as a multi-user operating system, so there are many users, and now Linux offers you freedom to, like as we have seen, freedom to fuck up your system, right? But I can't remove it. Let's say I can't remove this. Actually, let me see. Because this is owned by root, and what root is, so root is for Linux what an administrator is for Windows, and it goes much beyond that, because you can essentially do anything. You can change the code for the kernel, for that matter. So how do we change users? We use su command, which is for switch user. So if we provide the flag, let's say dash, then it's going to, so this command is going to switch the user to root. Now we don't have to type that much, we can just do this. Actually, I don't remember the password. Oh, so, and now whatever command we run, and this comes in the home folder for the root user. So this is the home folder for the root user by default. You can of course change it, and to exit the shell and come back to the previous user, you just have to type exit, and but what if you don't want to become root? Then you can use essentially something called super user 2, which is sudo. So sudo let's say ls. So you have to type your password, and it will run as root. Now bash is the shell. So whatever we are essentially doing here, it's going to, so let me just, yeah, so the shell in our case, which is talking to the kernel, is bash, and bash is the most the most famous shell that there is, and I'm using that. So if we do this, then the command bash is run as root, which means the shell is run as root. So now we have the shell for root. So we can actually do this to change into root, and so this is the last command that we have run. And if we want to run it again, let's say run the last command, then we just have to type these two exclamation mark, you can call them bang bang, and it runs it. So let's say we want to run the last command which had pyth as the first string. So we can type exclamation mark with pyth and it's going to run it. And this is it. So now if we do this, it's going to run this command. And if we do this bang bang, then it's going to run the last command. So that's it for this module. Oh yes, and actually where are these commands stored for that matter? So if you cd into the home directory, you can do this, or you can just type cd. That saves your time. Then you can see a file called .bash underscore history. So it must be here. Yes. So this file actually has a history of all the commands that you ran through the shell bash. So let's say we want to view it. And we don't want to scroll up actually, so we can do this. And we don't want to type this again, so we can do this. So these are like the last n commands, I don't know the value of n, that are stored. And now there's something called the package manager. So for installing anything on Windows, you need a .exe file, and then you need to download it. But that's not secure, right? Because anyone can modify the .exe file, and anyone can host it on their site, and you can essentially download and install a virus. So for Linux, there are many package manager, and for Debian and its derivatives. And since I'm on a Debian derivative, which is essentially NTX, but it can be any distribution which is derived from Debian or Debian itself. We have a package manager for apt. So let's say we want to search for a package called vim. So what we do is apt cache. So this is the cache for the aptitude package manager, and then we tell it to search, and then we say the package name, say vi. So there are many package names, and I'm going to terminate that. And so we can essentially pipe that to less, so that it saves us the trouble. And yes, it does. So these are all the packages which somewhere have the word vi in it. Now let's say I want to search for Chromium, the browser. Again, I want to type that to less. So what it does is it's taking this output, and it's giving that to the command less. Yes. So what if you want to install something? Let's say the web server Nginx, and don't worry what Nginx is or what a web server is. We are just here to install something. So if I do sudo apt-get, now apt-get is the downloader for the aptitude package manager install, and then let's say Nginx, the web server. Now it's saying that Nginx is already the newest version because I installed it yesterday, but it should install it for you. So, and actually Chrome is not here in the aptitude package manager. So there are essentially many things that are not in the aptitude package manager, right? So how can you get them? First of all, you need to fire up a browser. In my case, I'm firing up Chromium, and I'm going to say download Chrome. Now this is actually going to oh, this is actually going to give me a .deb file. And if I download this, I will get a .deb file, right? Yes, this is for Debian and Ubuntu and its derivative, and this is for the flavor. So actually, because of these package managers and many folks coming from the first two or three distributions, then the first two or three distributions which has many folks are actually called flavors of Linux, because there are many distributions that come from. So Debian is a flavor, Red Hat is a flavor, Fedora essentially is a flavor in itself. So that's a flavor, and for the Debian flavor we have the .def as an installer. So let's say I want to install this. It's going to download something. We need to wait for a second, or maybe many seconds. Which is disgusting. So it's downloading into my downloads folder, and that's where I need to install it from. So let's do some smart work here, right? First of all, this is the command for clearing the screen, in case your screen is cluttered up like mine. And now I want to change directly into my downloads folder, and since there's just one folder which starts with this string, so we can do this to save time. Now I'm in downloads folder, and now there are essentially many files in my downloads folder, but I just want to get Google Chrome, right? So I do this. So it's let's just forget grep for now. Alright, we are doing dpkg -i. -i is for install, dpkg is for Debian packages, and then Google start.deb. So what it does is anything starting from Google, then it has something in between, and it's ending from .deb. So this is the file starting with Google, something in between, and ending from .deb. So we don't need to type that actually. Now it's going to take some time. Let's see if we can. Yeah. So till it's installing, we can actually do this, which is sudo apt-get update. So this is actually taking data from somewhere, right? So where is this downloading from? Where is this download Nginx from? There should be a server, there should be something, and yes, there is, which is /etc/apt/sources.list. So this is the list of all the sources. This is the list of all the sources that the aptitude package manager downloads from. So I'm actually a minimalistic guy when it comes to my computer. So as you can see that I want performance and I want security. So I have like 4 or 5 servers to download from. So you can actually configure that where you want to download from, and let's say you want to update these sources, you want to update the repositories that these are downloading from, so you can update these by typing sudo apt-get update, and this is going to essentially update the sources.list file and its repositories. It's going to take some time. Oh. Yes, so we have this installed, and to run this we can essentially type in the command Google Chrome. Is it yes, I don't want this. So just fired up Chrome. So this is how you install software which is not in any repository in the aptitude package manager, but just just make sure that there is before doing this, because it can lead to security risks. So yeah, and let's say there is a new version of Nginx. I want to upgrade it to the newest version, so I type this, and it's saying Nginx is already the newest version, but oh no, I don't want this. So yes, so it's going to ask you whether you want to update or not, and I said no because I don't want to. But essentially we don't know that what packages have new versions available. So we can just type sudo apt-get upgrade, and it's going to upgrade all the packages which have newer versions available. Let's say there is a new version for Chromium or a new version for Nginx or whatever, then it's going to upgrade it. And I don't want to do this right now, so I'm going to say no. So this is how you use the package manager. Yeah, and let's say you want to see if you have Chromium browser installed. Yes, it's installed, and there are some updates, whatever. So first of all, I installed this, then it was upgraded to this, or so if I want to install something without typing sudo, so it's essentially what this is doing. It's installing something, which means it is changing the system settings, and for changing the system settings we need to be root. So let's say I want to just do this. Yes, so this is basically a permission error which should tell you that you need to be root. So we can actually become root and do that, but who wants to do that? So we are going to do this. Yeah, it's already new version available. Alright, and now if we come back into yes, so what this command does is it goes one level up in the file table, then it goes to the session directory, which means my home directory first and then the session directory. So that's the power of relative file names. Now if I actually do long listing here, then I can see that it's showing me dash, which means that this is a file, and it's showing me something like rw and all. And what this means is that I have read permission, I have write permission, and I don't have execute permission. So there are three permissions for a file for every user. Let's say I have a multi-user operating system, and there are many users using the same operating system. So I want to protect my files. I want to tell Linux that yes, this guy should be able to read the file, this guy should be able to write to the file, this guy should be able to execute the file, and this guy shouldn't be able to do any of that. So what we can do for that is use file permissions. So the actually if I go to the slide, so this is the type of the file, which is either a file or a directory. Then these three permissions are for the user, which is who is viewing the file. So for this user, so I have read write permissions but not execute permissions, because this is not an executable file. So let's say I want to do this for the ls, which is an executable file. So I have read, write, execute permissions right here, and actually I can do this in a smarter way if I don't know what this is, instead of just copy pasting and yes. Yes. So I have read, write, execute permissions for this file because this is an executable. Now that next we are for the group. So for a multi-user operating system, you need a group of users for which you want to define permissions collectively. Let's say for 2 or 3 people, you want to define these permissions. So you can actually just do that by creating another group. And actually, every user has their group. For example, this user has its own group, another user has its own group with the same name. You get the point. And this is for others. So this is for the user which is viewing it. This is for the group which is viewing it. So the groups in which this user exists, and this is for others. So let's say I want to, you know, create a file. No, sudo test file. So I ran it as root, right? So what this means is that this file is owned by root. Now if I do this, I have all the permissions, but as you can see, this file is owned by the user root and the group root. So how can we change the ownership? We can change the ownership by using a command called chown, which is for change owner or change ownership, or however you want to interpret it. Yes, so for the user, this, for the group, this, and before the colon, it's for the user that you need to specify, and after the colon is for the group. So I'm going to change the user for this file, and it's going to say show me an error, a permission error, which is because this file is owned by root, so only root can change the ownership. So I need to run this as root sudo bang bang. And now if I list it again, now this file is owned by the user root and the the user, this user and the same group. Now I can also change it to like this user and another group, let's say root. So I can do all sorts of stuff with this, right? And let's say I want to add some permissions. Let's say read and write permissions to this file. So what I can do is, now this user owns it, so I can change the permissions to this file. chmod 664, which is for read and write, and I'm going to get to how in a second. Now it's going to give me give all the users read and write permissions, which wasn't here for me. Which means that for this user and for this group, now I have read and write permissions, which means now I have for my user and for my group also. And for understanding numeric permissions, you can actually see this cheat sheet. I will link it in the description. Basically, it's just octal representation. Some of the octal representation, and there is a symbolic representation also. Let's say you want to add an execute permission to this file, so you can. So what you can essentially do is like chmod plus x, which means plus execute, or plus r, or plus w, or whatever, plus execute file. So it's going to change it. So now I have execute permissions for everybody, for the the group and for the user. So with that said, I have a pun here which you need to solve, and the find command. So I want to create a directory, right, for this. Now it's showing as a green file because Linux is treating this as an executable file because I added execute permissions to it, so I can actually run this, but it won't run though. Yes, so I can actually run this. Now if I see what kind of file it is an empty file, and I can run this because I added an execute permission. Also, I need to get rid of this, and I need to create a directory, let's say, and I need to touch many files, let's say abc.txt. So it's going to create all these files, and now I want to find the files which have the extension.txt here. So what I can essentially do is run the file command and find command actually. So find, and then the directory in which I want to find. So I want to find in this directory, the one that I'm in, my present working directory. So I will do this, and the type of file that I want to find is not a directory, it's a file. So this, and then the name should be something.txt. So anything.txt, and I run it, and it's going to find this dot slash abc.txt. Now I also have this one, but the case is different. The alphabet's case is different. So I can actually ignore the case by appending an I here, I name, which means ignore the case and then see if this name exists. And yes, it's going to ignore case and see if something.txt exists, and it does. So I can then do the same for POI files. I can do this. For this file, and that should explain. Or we have, yeah. So let's say that I want to find files. First of all, type file that are not of the extension .py, and I want to ignore the case for that. So I will do the same. My name .py, but in this command I'm going to actually add another flag called -not, which means something which is not this. So anything that doesn't have .py in the end, ignoring the case. So it's going to show me all other files which don't have py in the end. So that's it. These are some advanced commands. For example, let's say that there are essentially many directories in /etc, right? So we want to search recursively, but we want the depth to be 1, which means 1 folder at max. So let's say find /etc max depth, which is the maximum depth of the recursion, 1. So, and if you don't have a doubt here, right? This is antics. So up till this, everything is clear, right? Just tell me in the chat box. Yeah, so I don't see any downside here. So I'm going to enable recursion, and the maximum depth of the recursion should be 1, which means that it's going to go 1 folder inside the directory that we mean to search in. So let's say we know we want to search for the type file, with ignoring the case for the name, like is there anything ODB star, right? So that is going to do. That's what it's going to do. And if I don't actually do this, then it's going to enable recursion, which means that it's going to it's going to go inside every folder that there is, and every folder that there is inside that folder recursively. And there are some files for which I don't have the permission, so I'm going to show this to you by running it as sudo. Yes. So that's the point. And let's say after the finding is complete, I'm going to find something that exists. For example, in the bin directory, I'm going to find something that has zip in between. So yes. Now after this is done, I want to only see the files which have zip2 in it. So I'm going to do this and then dash exec, which means after this execute grep zip2. What the fuck? Oh yeah, actually I should have shown this to you. Size of more than 10 KB. So all of these are, let's say, size of more than this many kilobytes, and there is no file which is of size more than this many kilobytes. Let's say 100 kilobytes, nothing. Oh, yeah. These are actually small files. Now comes enter the grep command. Now, don't actually worry what these directories and files mean. I'm going to come in like a few moments, but so let's say that in this file I want to search for anything that has key within it. So what I'm going to do is essentially grep, and so the pattern is grep pattern and file, which means grep is going to search in this file for this pattern. So I want to search let's say for the pattern key, anything that has key within it in the file sssd config, and it doesn't exist. Wait, what? So it doesn't really exist. So let's say I'm going to go into the downloads folder, and then I'm going to only list the files which have Google somewhere within it. So Google star dot, and dot means for this directory. So I can actually do this. I can take the output of ls and pipe that, and it's going to search for the pattern Google and anything that comes after that in the output of ls. So that's it for grep command, and you can actually ignore the case sensitivity. So for this I'm going to again go into etc ssh and search for anything that has key, and I want to ignore the case dash I, and then I want to search it as a SSHD config. It should be there. Yes. So as you can see, it has a lowercase key and an uppercase K with a key, and all sorts of stuff. So that's not going to go. Actually, it's giving me some permission error, so I'm going to run this as root. Yes. So this is the line. Alright, with that being said, I think grep is done right now. Yes, and there are essentially many lines in this file, right? So how do I know that on which line our search string is? So I can do this by typing dash n, which is for including the line number. So it's on so it's saying that it's in the file sshd underscore config on line 19. Now what all of these files and folders have a meaning, but we are not going to get into that in this session. So we are going to come into our session directory and see what's on the agenda. Now I want to you know store this output inside a file, this output right here. So what I can do is I can use a what's called a redirect. This greater than symbol is for redirect, and then I can say like I want to store it in the temporary folder under the file name f. Okay. Now if I see what's inside this file, it's the output of this command. So I can run any command, let's say pwd, and then I'm going to store this in the temporary directory inside directories. And if I see what's inside, yes, so it's the output of the pwd command. Alright, so we're done with this redirection. Oh yes, and but this is not showing the output on the screen. If I'm doing this, then it's just redirecting the output to the file that I wanted to redirect it, and I actually want to see the output. So I can do pipe that to the t command, and it's going to do that. So process management. So whenever a program is run, it goes into the process. So let's say I want to run Chromium. It's going to consume my RAM, but so it's running, and I can actually click on a new tab and have a new tab. I can hit Control W, or just click this and do this. But if I were to hit Control C, then this process would end. Now this program is running, but there is a process running in the RAM for this program. So if I end this process, then this program will also end. So for ending this process, I can hit Control plus C. So you can see that I don't have the prompt here, which means if I run any command, it's not going to run until the prompt has appeared. So if I hit Control plus C, it's going to end the process, and now the program is gone. So if I were to do this, now I can click on new tab, I can hit Control W, I can hit Control T, and it's working. But I want to pause this process. I don't want to stop this process, and I want to pause this process. So I can hit Control plus Z. Now this is stopped, which means it pauses the process and puts it in background. So if I were to hit on any link, it's not going to work. If I hit on new tab or anything, it's not going to work because it is paused and put in the background. So how do I put it back in foreground? Well, these types of processes are Is it back? I need you guys to tell me if it is back. Well, the packets seem to be moving, so it seems to be back. But anyway. So it seems like I was just, you know, talking for like 5 to 10 minutes, and some network error had occurred, so I couldn't be seen. So where did the stream, got stuck? I need you guys to tell me what part I was discussing before it was stuck. Where was it stuck? I need to know. Okay, so we are going to start process management from the ground up again. So so let's say I want to run something. Let's say I want to run Chromium. So this program runs as a process, and this command top displays all the processes in real time, which means all the processes which are running, what are the command lines. And so if I do this, I can see that this user ran this command at this time, this user ran this command at this time, and all sorts of stuff. And there's a weird thing called PID here, which means process ID. So e- every process essentially has an ID with which we can control the process. So in Windows Task Manager, you can't you can actually just kill the process and stuff like that. But in Linux, you can do anything with the process, and it is with this PID. So what we are going to do is hit Q to quit it. We're going to clear the screen, and the process ID is like 5502, right? So I'm going to kill this. I'm going to stop this process, like shut it down. So I can do kill -9. What was it again? 5502, right? Kill -9 5502, and it's going to kill the process, which means we are no longer going to have this process running here. So that was about top, but there is another command for process management, which is PS, which is ls but for processes. So PS, if we use -aux, then it's going to so top is for processes in real time, which means it it's going to change. But for the time for this when this command was done, we need ps-aux. So this is the list of the processes for the time in which that command was run. So if you want to see what processes have Chromium, actually I want to run Chromium before I do this. So I'm going to grep Chromium here. And I can see a whole lot of stuff. So I'm going to find that to less and kill the process. Actually, I want to. It's I guess this is 6225. Yes, 6225. So I'm going to kill this process. -9 6225. 4 or something. It's 6388. Alright. Yes. And so as we can see that again this process is killed. Now there's also a process for grabbing every process which has chromium inside this. So this is the command with which this process was run. So I want to see every process which has chromium in its command line, which means chromium was somewhere when this command was run. So there's nothing, which means I need to run this again, and yeah, run this again. And these are all these processes, so I can kill these. So I can actually there's a command for killing all the processes. So I can kill like 6942 and then 6959, all sorts of stuff. But if I want to kill every command which has chromium inside it, I can use the command chromium kill all. So you're going to kill all processes, and as we can see that all the processes for chromium are killed. So that was about process management. I'm not going to go into the nitty-gritty details. And these are the services or daemons are basically you know customized type of processes, special type of processes that don't consume much memory. For example, if I have a web server, then I don't want it to exist as a normal process. So I'm going to install a web server, say install nginx, and then I'm going to sudo service, which is start. So I'm going to start the service nginx, which means that this is already running. I guess nginx start. Yes. So if I run chromium here, and I'm going to see if this is actually running, I'm going to type localhost, and it's going to show me the nginx page, the web server. But if I were to stop this server by typing sudo service nginx stop, it's going to take a while, like a few seconds. Alright. And now if I were to refresh this, then there is no longer a web server to run on my computer, so it's not going to show any web page. It's going to take some time. It's going to do some internal routing. Until then, yes, so as we can see, it's going to do some internal routing and then show that it's not connected. Alright. So if you were to change the port or any configuration, I believe it's in /etc/nginx. Yes. So if I were to change any configuration, say I'm going to change into the configuration, let's say anything, and then I want to stop it and then start it, which is not going to be convenient. So I'm going to say sudo service nginx restart. It's restarted now, and if I again visit this localhost, then it's going to show this. It's going to show me this, and if I were to stop it again, and type localhost, actually it wasn't stopped. So if I were to restart it and then again type localhost, it's going to show me this. But if I don't want to stop, I don't want to change the configuration and then stop it and then start it. I mean, it's a lot of work, right? So I can do this sudo service nginx and restart. It's going to restart nginx. It's going to start and it's going to stop and start nginx in succession. But in the real world, this command is not used because there's a more low level command called system control. So if I were to do system ctl nginx stop, it's essentially going to, what the fuck, Okay, so it doesn't exist on my distro, but this is actually thought of as the low level command for doing this stuff. So that's it for processes, I guess. Services. Now we want to schedule tasks. So let's say I want one command to run. So there's a file called cron tab, and I can edit it by typing cron tab -e. Is going to open this with nano, and this is the format, like minute, hour, day of month, and day of week, and then the command. So I'm going to do this for, what's the time right now? It's 11:21. So I'm going to do this for 22, 23, 22nd minute, or 23rd hour, and doesn't matter day of the month, doesn't matter this, doesn't matter day of the week, and then I'm going to do like pwd /tmp /present. Alright, it's done. And now if I were to do this /etc, /tmp, and I'm going to grab anything that has present, I don't get anything. But as soon as the 23rd minute for the 11th hour of any day shows up, which is 11:23 for today, this is going to exist. This was scheduling tasks which are also called cron jobs. So come on, man. I guess there are many seconds left. Yes, now it should work. Oh, it's going to run on the 22nd minute of 23rd hour, right? Yes. Should work. 24th minute. So it's not working for some reason, but it should, and that's how it works. So there are many practical uses of cron jobs for system administrator. For example, upgrading all the packages, and this -y actually means that it's not going to ask, do you wish to continue or not. This is going to respond yes to that, and every 7 a.m. of the first day of week, which means Monday, this is going to upgrade all the packages. So this is an example of how cron jobs can be used, but you can use them for anything. Why it is not working anymore? So there's something called Linux is a multi-user operating system, right? So what we can do is we can come back to our session directory, and we can change switch user, which we have already done, to root. We are going to enter the root password and become root. So let's say we want to add a user called anon. So user add, this is going to add a user with this username, so it's added. So if I were to do this now, I think there is some other. So I want this user to have a password. Oh. Change to root, and then I want this user to have a password, so PSSWD, and then that user. I enter the password, I retype the password, I don't miss. Oh fuck. Password updated, and now if we were to change, if we were to come back to our user, and now we were to change to that one, we are going to type that user's password and become the user. So if I were to type who am I, which is for knowing that what user I'm logged in as, I can see this, the new user. So I can do all sorts of stuff here. So if I see what the home directory for this user is, it's this. The directory in which I created the user becomes the home directory for the user that I created, right? So, so when I said that you can change your home directory, or you can have any directory as a user's home directory, this is what I meant. And now what we're going to do is we are going to exit it, exit the user, we are going to become root, and we are going to change the password. Now root has access to anything, it doesn't need to know the password of this user to change it. We can just have this changed. So that's it for creating a user, and now we want to delete the user. So we are going to type a user and bye bye user, and it's done. Now job management. Now jobs are essentially processes, but they are managed by the shell. Now the programs that you run, they are managed by the kernel. So those processes are managed by the kernel, but there are essentially some processes which are managed by the shell. Now you can program on the terminal, and I program on the terminal, and this is actually one of the greatest tools at my disposal, job management. So what I essentially do is, let's say I were to run a process called Chromium. It gets run, and I want to stop this process. Then I'm going to hit Control C, and it stops the process. Now I type Chromium, it gets run again. I can create a new tab, I can close a new tab. But if I were to type Control plus Z, then what it does is it stops the job, which means it pauses the job and puts it in background. So Control Z for that, and now if I were to Control T W or whatever, then it's not going to work. So how do I put this job back in the foreground? So if I type jobs, then it's going to show me all the jobs that are currently exist. So there is only one job with job ID 1. So I can fg%1, which brings the job with job ID 1 to the foreground. So it comes in the foreground, and now we can again stop it. Now we can add another job. This is 300. Stop it again, and then we can see what jobs are there. We can put second job in the foreground, then we can stop it, like terminate the job. Then we can put the current job in the foreground, which can be done by using percent plus or percent. It brings it in the foreground, and then I can just I can run this job, but in the background, which means that I still want the prompt. So percent one, I still have the prompt, but it's running. So that's essentially it. I want to close this now, Control C, and that's I guess that's it about job management. Yes. So you can essentially do this. You can like run sleep 100, which is going to hold the prompt for 100 seconds. You can do this, and then you can like have a any job, any and all jobs in the foreground, which the command line of which started from sleep. So this is the job, and I can like do sudo, and I can bring it, I can terminate it, and I can do sudo sleep 100, which means that sleep is not the word which is in the starting of the command line of this command. So what we're going to do is add a question mark here, which means that any command which has this word somewhere within it, this one. So that's a command line. I'm going to terminate it, and that's it for job management. So I actually write code with this. For example, let's say code.py, and you should understand it. I do this. Then I don't like I save it, and then I hit Control Z. It stops, and then I like run it. I put it back in foreground. I can type something. I do this. Then I can run it, and all sort of stuff. Like I can run vim and type something, and then escape and run some command to come back. So this is actually a great tool at my disposal. So that's it for job management, and I'm not going to talk how I actually code with this. So because of the time. Now comes the best part and the longest part, which is introduction to networking. And I'm going to be really fast on this because networking is a big topic in itself, and I can't cover everything in 1 hour, and I don't want to. What I want to do is give you sort of a ground from which you can level up. So the internet is actually based on the suite of protocols called TCP over IP, which means transmission control protocol over internet protocol. Now a protocol is essentially a set of rules which is followed for an operation. So the transmission control protocol is the set of rules that all computers on the internet use to ensure the delivery of the data that is sent from one computer to another. And IP is responsible for the logical addressing, which means that there are essentially millions and billions of millions of billions of computers on the internet, and we want an address for the data to reach on the right destination. So internet protocol takes care of that, and what it essentially does, it assigns a unique IP address to everyone, and the internet works on the client server architecture. For example, the server of Facebook or Google is a server, and your computer is a client, and you essentially connect to the server, and then you request data from the server, and then it responds back to you. So what we are going to do is we are going to start a server. -V means verbose, L means listen, on port I'm going to cover in a second. Then I'm going to start another terminal, and I'm going to say, and I'm going to connect to this server. So this server's IP is this, which means the IP of my own machine. I'm going to connect on that port, and let's say I say hi. So this data is transferred here. So this is the IP address. So this takes care of the IP address, the destination and the source of the data, which is actually sent in small chunks called packets. So if your internet connection was slow for like any amount of time, and you were loading an image on the internet, then it comes part by part, which means that the packet valid IP. You get the point. So that's it, and there are many ports for that. For example, let's say you are running a website, so you need a web server, you need a database server, everything running on one machine at the start when you just have one machine. So for that there are 65536 port for each IP, which means number from 0 to 65535. So you can use any of these ports for anything. For example, I guess I have Nginx still running on my computer. So what I can essentially do is like localhost colon 80, and my web server is actually running on port 80. So just connect to my computer on port 80. That's what it is. And there are essentially 65536 ports for that. So I have port 22 for OpenSSH for remotely accessing my computer and stuff like that. And then uh, there are essentially 256 to the power 4 number of IP addresses that you can assign with this notation. So there are essentially this many IP addresses, but an average person has around 5 devices which are connected to the internet. So this actually is not enough, which is why subnetting came into play, which means that for one IP address we can have a whole like this many IP addresses for one. For example, just for the sake of example, I'm explaining 1.1.1.1 is your IP address. Now you want to have a network within you, and to ensure the delivery of the packets, if the packet comes to this computer, and then it has to send that packet to any computer which is inside the network. So we can have like class C IP addresses, which is like 0 to 255. So like you can have 1.1.1.1, then 2, then 3, then 4, then 5, then 6, and you get the point. And then you can have this many IP addresses, and then which is actually class B, and then there is class A, which is like so one computer can host a network with this many IP addresses at the maximum when subnetting came into play, but this was also not enough. So network address translation came into play. So I was actually using this IP address for denoting my computer, and network address translation does just that. So if I were not connected to any network and still ping it, I would get a response because this is my computer. And if I ping like 127.0.0.1, that is also my computer. And so NAT basically translates IP, which means that the router knows the actual IP of the machine, and the packet actually comes to the router, and then the it is the router set up to translate the IP address and then send it to that, so that that's how internet is running right now. And now we are going to start some coding, and for that I have like a laptop which has essentially an Ethernet card and a wireless card. So how do I know? I can type if config, which is going to show me all the network interface cards. So this is the virtual card. So if no card uh, exists on your computer, then this exists for the internal routing, like for stuff like 127.0.0.11 and stuff like that. And this is my wireless interface card, and this is my Ethernet card. So that's how it's happening. And TX means how many packets were transferred from, and RX means how many packets were received. So if I were to see here, geez, this many packets were transferred, and actually these many bytes were transferred, and these many bytes were received by the local loopback. So, and now I want to monitor the packets which are actually coming to this. So if I run TCP dump, oh, I'm going to install it. Alright, so I'm going to run TCP dump for seeing all the packets on all the interface cards, and uh, you can see that I don't have permission, which means I need to be root. And it's listening on W10, so if I like yes, so these are all the packets, and it's not going to stop. So I'm going to add a counter to it, like 10 packets at max. So this is going to listen for 10 packets and then stop. Now if I want to just capture on my wireless interface, so essentially do this for 10 packets on my wireless interface. It's going to end in a second because there is a stream going on. Yes. It's going to end in a second, even if it doesn't, I want to proceed. Alright, so that's it. And let's say I just want to capture on port 22, so I'm going to say port 22. And TCP dump needs a class in itself because it's like a huge topic, and there is nothing going on in my SSH, so I guess I'm just going to have to exit it. And now I want to get the network statistics. So there's a command for that, netstat, and dash nr essentially means dash n means that we're going to show these are dotted IP addresses, and R denotes the that we're going to get data from the kernel routing table. So these are all the connections on interface, on my wireless interface. This is essentially, I guess this is my router. No, I guess this is my gateway, and this is the IP that is going to. So I guess this should be my router. So that's that's how to get the kernel IP routing table. And now we have now we want the usage of each interface. So I guess my Ethernet was never connected, so it's not using anything. My wireless interface is connected, and the local loopback is basically always connected because it's a virtual card for the computer. So let's say I'm going to run, and I wanted to this in IP notation to end, so that this actually shows the connection and the states. And the I guess this is the connection for my stream. because it's established and it's sending, and these are all in listen states. So it's going to show me the local address and the foreign address and all sorts of stuff, which we're not going to get into right now. Now, let's say I want to ping localhost. How does it know that localhost is my computer? Now, there is a file called host configuration file in /etc/home, and as you can see that it maps the given host name to an IP address. So this IP address essentially means this computer for any computer. And if I were to exit and like ping this one, then it's going to do that. So let's say I'm going to code forces. So this is for codeforces.com. Now I want this to have a special name for me, so I'm going to type here. Like first of all, I need to get the IP address of codeforces.com by typing this. This is the IP. I'm going to copy it. Shift Control C. I'm going to open this. I'm going to like. I'm going to add here like CF, cf.com. Tab CF. So this is so if I were to now visit say cf.com, it's going to open code forces or cf slash. I guess code forces has some internal routing going on in it. So let's try like a site that I know will work. Let's try geek for this. Let's just hope this doesn't have an internal routing going on. Now I'm going to restart my network manager. Sudo service. No, actually that would be stupid because I have a stream going on. Yes. So now if I type gfg slash, then it so this is sort of a internal domain name server, which means that for any name first it is going to look in this host configuration file, and then it's going to look into the DNS server. So I don't want this anymore. I'm going to close this, and now we want to set the host name of this computer. So I'm going to type sudo hostname ctl. Now I want the name as I don't have this command, so I'm going to install it, and I'm not going to install it. Now let's say I want to visit google.com and see what computers my packets were hopped onto. So first I'm going to trace the route to let's say google.com. which me so if I send a packet to google.com, it doesn't go from my computer to google.com. It first goes to my router, and then my ISP, and then some company, and then you know so they are called hops. The packet is hopping from uh, one IP to another. So I'm going to essentially see all the hops for the route to google.com, and first it goes to my gateway, my router, which is actually my phone. Then it goes to I guess this is my ISP. This is going to take some time. And this three asterisks mean that the request timed out for this IP, so it just hopped into another IP. Connection timed out, and I'm not going to trace it. Actually, I'm not going to trace it. So that's how it works. Dot 168.43.1, and it's actually my phone, so I don't think it's gonna respond. Yes, so I'm going to actually scan my own system. So it has port 22 open for SSH for remote access, and port 80 like I said for the web server, which is actually which actually runs HTTP behind. So that's it, and you can actually like do 0 0 0 0 and 1, which is going to only return for 0 because 0. So it's going to reconnect to that port. So this wildcard character is going to try every IP address 0 0 0 1.2.3 and everything, and only return for 0 0 0 0 because of the other IP address don't exist. So that's how we can use Nmap. Now Nmap is also a huge program in and of itself, and so we're just going to get the basics of it. And for remote access, actually we can like sudo apt get install open SSH server. What this does, it gives you remote access for the shell. It's actually already installed. So service sudo service ssh start. So I guess it's already running, and if I connect to it SSH like and I'm going to until it's installing, we are going to do some other thing, which is like change the port. So it runs on port 22, but let's say you want to change the port for security reasons, which is like the first line of defense. So this is the file. Here is the port. I'm going to change it to like 1337. I'm going to sudo service ssh restart. Yes, and then I'm going to it's still installing. So if I were to connect with the same command now, I would need to this is installed on my phone, and now I can like run anything. So I can essentially run any command and just log in the history file or something like that. So to exit the connection, I just exit. It logs me out. It closes the connection. If I were to stop my OpenSSL to get a file, LLS is for local listing. Actually, let me just do this. So if I do like SFTP, uh, so let me just start it again. Upload the file, it's uploaded. Let's say I want to get something, let's say I want to get all the screenshots. So I get screens. So that's it. That's how you get the screenshots. So that's how SFTP works. So if I were to exit it and see, I have all the screenshots here, and if I were to go into the home directory and see that. So now we are going to stop this because we don't have the time. And on a side note, actually I would tell you to read the documentation or the fucking manual. You know, this is a term used in cybersecurity, and these are all the options. And if I want to know the options in specific, I can do this with any command. So there's some network error because of which is glitching. So yeah, there was some network error. We were done with. I just type this for any command and get it. So that's it for that. And at last, I will just tell you to live in the terminal, because you know if you were to pop some shell, hack a Facebook server, then those servers there need high performance, and they're not going to have any GUI. They're going to have shells. So to become a hacker, you need to be, very fluent with the shell. Uh, and GUIs are sort of bloated. And if you learn these commands to run on any POSIX compliant machine, which is like loosely said any Unix like machine like Mac OS and OpenBSD, Linux, all the Unix like machines, the commands and on the shell or the terminal are the same. And from the command line you can just configure anything. You can compile a kernel for your own machine. You can rename Debian as my Debian or your Debian or whatever. You can do anything. And Unix utilities do things best, just like Vim. Like you are going to not use any IDE if you use Vim. So that's like the best code editor that's available, Vim. And some people use Emacs, but Vim sort of makes more sense. So uh, and in the terminal you can achieve flexibility through pipes like I showed, substitutes like echo backtick date, and you can automate complex tasks like having cron jobs or having shell scripts, which I couldn't show because of the time. And that's it for this day.